Hey everybody, my name is Farhan Ture. I am a technical fellow at Comcast, focused on natural language processing. So I am involved in a lot of different R&D projects at Comcast focusing on natural language processing. Comcast is a big corporation for those who don't know. It includes Universal Studios, it includes Universal Pictures, NBC, and then there's a Comcast cable division. And under that Comcast cable division is where it's mainly focused on providing internet and phone and cable TV and home security services to its customers. I am part of the technology and product organization there. And more specifically, there's a Center of Excellence for AI called Comcast Applied AI Research Group. That's the team that I'm part of. So today I will be talking about the round-trip system that we have built at Comcast. And this is in collaboration with all of my coworkers that you can see up there. It was a very collaborative project that I'm excited to be sharing with you today. So let me start with some background. The Comcast Applied AI team develops a voice AI engine that powers multiple voice-enabled products all around the world. And the products that we're talking about here, the way I describe them is these are entertainment operating systems. So similar to Google's Android TV or Amazon's Fire TV or Roku, essentially an operating system for your TV that allows the user to be able to view the content catalog, browse the content catalog, to get personalized recommendations, to change the settings, and to be able to, of course, play content directly, and to provide a voice interface to do all of those things. So that's the product landscape that we're talking about here. And more specifically, the products that you see on the right-hand side on the screen are the ones that are powered by Comcast technology platform. So let me walk you through these a little bit. So it all started in 2015 when Comcast introduced the Xfinity X1 system, which you can see on the upper left. So this was its flagship product for Comcast customers in the United States. It allowed customers who subscribe to Comcast services to basically get this operating system experience on their TVs. At the time, it was very new and very well received, and it came with a voice remote that allowed a voice interface, a part of that operating system. So later in the years, this was actually expanded in North America, in US and Canada, through some syndication deals with competing companies that actually wanted the same technology. So the companies that you see below the Xfinity X1 are all companies that brand this product based on their own brand, but use the same underlying technology. And then in North America, through X-Class TV, which is a standalone TV, again, the same technology is basically preloaded on those TVs, and the folks who bought those TVs and are using them are, again, leveraging the same platform in the back. And through partnership with Sky, which was acquired by Comcast a couple of years ago, this was further expanded into Europe. So now there are 4 or 5 countries in Europe where customers of Sky are able to, when they're using their Sky products, are leveraging the same voice technology platform that was built by Comcast, and the voice AI engine in the middle here. So all in all, the AI in the middle is receiving around 40 million on average commands per day. The team has done a great job over the years developing the AI in-house and building a lot of the components internally. So I've listed some publications on the left-hand side that you can see the timeline of the development of this voice AI. Most recently at EMNLP this year, a couple of months ago, we presented our first full speech recognition system that we developed specifically for entertainment, which is now running in production for X1 customers. So if you're interested in any of those, please let me know. We can chat more about those publications. But today's talk is actually going to be not looking inside that AI box, but it's going to be about how do we test the behavior of that black box. So really, for a moment, not thinking about any of these products specifically, what we're really interested in is, there's a user in front of their favorite screen, whatever that is, a TV or something else, and they're looking for some good entertainment, right? And our goal is to be able to provide a voice interface that will allow any user to be able to find any content easily. Right, and aspirationally, we don't want this AI just to be intelligent and accurate, but we also want it to be fair and equitable. And we understand it is very challenging, and it's even challenging to define what that is. But it's really important, it's core to the mission of being able to provide this technology to everyone who uses it in an equitable way. So just to restate, the motivation for this work is to implement a scalable evaluation system for voice interfaces on TVs. Right, so you might be thinking, why is this a hard problem? Aren't there already solutions for this? And there are a lot of, good techniques that we have been using over the years. You can create test collections through sampling methods, you can use A/B testing, and these are all good ways to test these AI systems. But also over the years, as we've scaled up, and also as we've gotten more diversity in the users that are using the systems, we've noticed that there are some areas where this is not sufficient. Right, so let me share some observations we've made through real situations. So one of them is the content catalogs are big and they're getting bigger. Right now there's all these streaming wars, so to speak, and there's just a lot of fragmentation and scale of content. But the catalogs are not just big, but they're also ever changing, right? They keep refreshing. And a lot of the changes in these catalogs are through events. They're driven by events. These events come and go very quickly. So you need to be really proactive if you want to test your system. You can't wait for an event to happen and then see how people are interacting with voice interfaces around that event. So let me give you an example. Olympics comes every 4 years. So if I wanted to test my AI for the upcoming Olympics, I could go back 4 years and look at the voice commands. But they're not really a good representation of what people will be saying into their voice remote in the upcoming Olympics, because it's an event of its own. And the athletes change, but also throughout the Olympics, what people say into their voice interface is going to be depending on what athletes do what, who is successful, what the controversies are. So there's a lot of things that are happening in the world that actually affect the distribution of data. And it's really hard to do that, to be able to test that because you can't really anticipate it. So that's one challenge. Second one's not going to be a surprise. A typical, when you look at the voice command frequency, we've, published some of this. It follows a nice, Zipf distribution. It's a very long tail. That's not surprising. But one thing we realize is that the existing testing methodologies, because the long tail is long, but it also accounts for a small percentage of traffic, they're not very effective, and they can often ignore that long tail because it doesn't really contribute too much to the aggregate metrics. But we don't really want that, right? We want to be able to look at the errors across the board, to be able to understand all the issues. And especially in the long tail, we've noticed that there could be some systematic errors or pointers of systematic errors that are affecting underrepresented groups of customers much more than the global population. And that is something that we want to really be able to understand well. The third one, especially with the discussions early in the morning and out in the news, there's always examples of this. And as AI gets more advanced, there's going to be more. The AI systems that we build, are great, but they can sometimes do things that are just surprising and baffling to the user. They can do things that are offensive to the user. And it just takes only one example for this to be really damaging, right? This can reduce trust from the user side, which is, something that we don't want. It can also create reputational problems for products and AI in general. So really, we don't really want to be in a position where we need to mitigate these kinds of bad behaviors. We want to be able to avoid them altogether. So avoid that to happen altogether. So these are really the couple of things that have been driving this work and has been the motivations for what we've built, which is a semi-automated evaluation system or framework for any voice interface that we call round trip. So at the core of this, some of this was discussed in the morning sessions. This is really a cultural and organizational challenge as much as it's a technical challenge. So one of the things that we've done with Roundtrip, one of the key ideas is to create a UI that can be shared organizationally from top to bottom, and to use that as basically the common framework for evaluating a system, and to share that. Making our evaluation as privacy-friendly as possible is an important principle as we've been developing this. And another important principle is to not drive our evaluation based on logs, which might have some bias in them, but to drive it based on a catalog. And I'll talk about what that means in a minute. And then finally, we do want to reach the tail end of the distribution. We want to build a system that can scale and be comprehensive like that, so we can avoid, again, like bias and blind spots that might happen otherwise. So this is really complementing other evaluation methods that we already use. So going into the details of the actual processing flow. So with Roundtrip, basically, we always start by taking one entity out of our catalog. And we take the entity's title and any kind of metadata that is useful, its unique identifier. And the first thing we do is we try to simulate what a customer would have said into the voice interface if they're interested in that entity. So here we're generating a bunch of utterances and corresponding API calls to the voice AI engine. The second thing we do once we have that run simulated is we look at what the customer would have seen if they went through that process, and try to capture that as precisely as possible, taking a screenshot of what they would have seen, any kind of classification that we can do of what type of behavior the system showed, and any other relevant information that we want to capture so we can expose that later in the UI. So at a glance, that's the approach, and we call it Roundtrip, because we start with an entity and we want to end up validating that we can end with that entity. So for the rest of the talk, I'm going to break down the approach into 4 different steps. So the first step is to actually make the simulation of the request to a voice interface. And there are 3 different pieces to this. One is to actually generate realistic text queries given an entity. So we're using a lot of the well-known methods out there and combining them into a multi-step process. So there's known nicknames and aliases that we can get from our database. We can learn how to create semantic variants of some text. And then there's heuristics that we can add on top of that, especially to cover some syntactic and lexical variations. Our goal here is to be able to over-generate all the different things, all the different text queries that could be relevant to an entity, and then we'll narrow that down later through different techniques that I'll talk about. So that's number 1. And the second one is, once we generate a text query, how to convert that into a speech, into an audio itself. And here, our goal is to be able to create the speech with the characteristics that are representative of not just the core user population, but also any underrepresented groups that we have identified, plus any new markets that the product might be going into. So we want to be able to control the data in a way that we can look at all those different aspects. We want this to be, as I said, privacy friendly. So our goal is to not have to use any real user voices to be able to do this. But we understand that, especially in the beginning, there needs to be some data to train a model to go from text to speech. So we've been looking at different ways of collecting that data. Obviously, there are logs that we can use to train models and learn from that. But there's also a lot of open source data that can be used. Plus, we found that it's actually very useful to collaborate with other companies to collect data, and to collect data in a way they can really control that, and it can be without touching the user's private data. The third piece is really a bit more specific to products, but we think it's really important as you're simulating requests to look at different types of contextual variants as part of the process. So some of these examples are like, was the user subscribed to Netflix or not? Are they using a hands-free device, or they're using a push-to-talk kind of device? What location are they in? Basically, any parameter that would affect how the AI would behave should really be accounted for here, so we can basically look at all the different angles to be able to do a comprehensive test. So for instance, if the user is on the home screen of their TV and they're saying Stranger Things, right? We might expect the behavior of the system to be to take them to a page corresponding to the TV show Stranger Things. But what if they're actually navigated already to the YouTube app and they're saying Stranger Things into the voice interface? You would expect then maybe to do a search on YouTube to show the user different videos related to Stranger Things. So the behavior could be contextually changing based on it. And that's really what we're trying to capture as part of C. So combining A and B and C is really taking us from one entity to many requests that we're simulating and are going to be sending to the voice AI engine. So the second step is to validate the outcome once we have run that simulation. And here is, our approach is to have an automatic way of categorizing the outcomes, looking at different, data. So the way we've categorized these outcomes is specific to the product experiences in collaboration with, product owners. This could be customized based on whatever product this framework is supporting. So in our case, we have gold defined as when we are actually seeing the entity returned on the screen, either by itself, a dedicated page, or when there are multiple things returned as the number one item on that list. So it's a very prominent position. A silver result means that the entity was returned either in second or third place. And the first three in the operating system that we are testing this on have a more prominent space than the rest. That's why I categorize that as silver. And then bronze is basically anything that is fourth or lower, so the entity is still recoverable. It is there in the results, but it's not as part of the top three. Then everything else is basically what we're flagging to be reviewed by a human, right? So either the system gave an error or the entity was nowhere to be found in the search results, so it really didn't come up. So the third step is now that we have generated requests, we've run them, and we actually have some kind of validation of the outcome, we want to scale this, right? We want to do this on entire catalogs with lots and lots of entities, and want to do this periodically so that we can proactively test the system as things are changing, not only in internal components, but also out in the real world. So, there's certain tactics like using virtual machines to mimic different kinds of situations and optimizing processing, but also we really spent time looking at how can we optimize the user experience, how can we optimize the data flow. So the fact that we have these 4 categories and we only need to have humans attend to the review category helps us scale this much better. Also, we have introduced this concept of stashing known issues so that there's a lot, among all the things that need to be reviewed, if there are patterns there that the root cause is common to a lot of those issues, they can all be stashed into one bucket, and that allows us to avoid repeated look at those test cases. So just to give you an idea, a sample run could be, let's say, over a catalog of 200,000 entities, and we create 1 million different requests into the system that we want to see what happens, right? And this could be a higher number. If 90% of them already fall into gold, silver, and bronze, because the AI system handles those well, and it actually knows, it can validate that it handled them correctly, then you only need to focus on the 100,000 requests that are remaining. And through reviews periodically as these runs happen, and through the stashing mechanism, we found that a lot of the issues that do come up in those 100,000 can be really grouped into things that we know are either being fixed or things that we know that all fall under the same type of issue. And through our practice, we found that 97 to 100% of the remaining ones can be handled that way, so a human doesn't actually have to look at them every time the run happens. So really, we end up with fewer things that humans need to look at. We still need to do that manual step, but we're able to reduce a lot of it through the automation. And really, the ultimate goal is for that number to be zero, right? You have a system running, you periodically test it with this approach, which is comprehensive, and you want to look and see that everything was, you're able to validate that everything was working as expected based on the principles that you set out. Of course, in practice, that's not going to be zero, but as close as it can get can be an objective for an organization building such systems. So the final step is putting all of it together into a UI, right? As I mentioned, it's really important that we, as a company building such systems, to look at this collectively. There's different roles that can be played by different people in the organization, and we think that a UI can really help make that easy, right? So we've identified a couple different use cases of such UI once built. So one of them is kind of more from the role of an editorial role, right? And here is where we want to be able to interact with the data much more, want to interact with the test cases and want to explore. This is where the domain expertise comes in place, and we really want the tool to allow for that. There's a senior management use case where it's really about tracking, right? Tracking how well the system is doing, and to be aware of the major issues that have been uncovered. And then finally, the development team, like the people actually building the UI, should also be involved in looking at the evaluation and being able to use that to dig deeper, right? That would be their goal, is to understand why certain things are flagged and are not working as expected, to be able to debug it right then and there in the UI, and also to give them ideas about how they can make it better in the future, right? So we can avoid those kind of more fundamental issues. So let me walk you through a prototype that we built based on this framework. So, here is just demonstrating, let's say you wanted to use this framework, this round trip framework, to be able to test for the World Cup that's coming up. So here is, a page in which you can look at different kinds of domains of usage, and you can create more specific test collections based on the larger catalog. So a subset of the content catalog, essentially. So here you can see that there's a collection of World Cup teams that are being loaded onto the tool. Once you have that collection, there's, the next step is to simulate queries. So this is where the tool itself has a lot of capabilities to generate variations, but it also allows the user to interact with that and to be able to provide some input so they can customize what that looks like based on the specific test that they want to do. And then finally, as after the run happens, to be able to look at the results, to look at in detail what actually happened on the screen. This has been powerful in terms of being able to see how the system is performing at a large scale, and to actually see what happens, which is really important for these kinds of products. And within this view, there's also ability to be able to stash things in different categories and so on. And then finally, a view in which we're looking at the metrics that we care about. That can be split into different kinds of collections. It can be aggregate numbers, and it also should be over time. And this really allows, what I mentioned as in the senior management use case, and really understanding how the system is performing, how improvements are being made, and how they're getting reflected in the key metrics. So with that, I'd like to conclude the talk. Voice is really increasingly becoming the interface for accessing content on a TV. There's lots and lots more content. There's streaming, there's news, there's sports, and there's a lot of different things that really voice could help do much better. And it could become easy. So the round trip system is a framework to be able to evaluate these interfaces at scale, and is being used at Comcast to run millions of tests every day, and it's really helped us uncover some of the issues that we couldn't before. So as next steps, we're looking into improving how we're simulating those requests, making them more realistic. I'm using different kinds of techniques there. And you might have noticed all of this is focused on entities, so looking at expanding the capabilities to non-entity types of use cases. Those are not the only things that people are looking for when they use voice interfaces on TVs. And then, more automation so we can actually reduce the human in the loop need as much as possible. And, there's a lot of different possibilities there that we can do in the future. So with that, thanks for your attention. Please feel free to reach out if you have any feedback or questions. For those remotely, you can send me an email. For those here, please come and talk to me. I'd love to talk more. And also check out our webpage, which is on the upper right side. We, as a team, focus on a lot of different things. This is one side of it. So if you want to check out what else is going on, and if you're looking for opportunities, we're always hiring, but also we're looking at collaboration opportunities. So I'd love to talk to you more about that if you're interested. Thank you.